Alright, holes. If a value of x makes both the numerator and denominator of the fraction equal 0, then the function has a hole at that point. I'm going to give you guys some steps, but basically if you factor this, two numbers that multiply be negative 12, that's 4 and 3. Add those together equals a positive 1, so this will have to be a positive and a negative. We'll learn about vertical asymptotes. We just basically set the denominator not equal to 0. I want to focus more on the holes and what it'll look like. So that's 3 and negative 4. Those are vertical asymptotes. And then you have 3 sections. Everyone count with me? 1, 2, 3. So you're going to have 3 parts of the graph. If I punch that into my calculator, I'm going really fast how to graph it. I just want to get us to a point to talk about the whole. X minus 3 divided by... You can use the original problem. Alright, we just took some notes on how... Do you see how the graph actually goes through what appears to be a vertical asymptote? Do you guys see that? And we just talked about, can it go through a vertical asymptote? No. So you should be kind of suspicious of what's happening there, because if you do something like this, look at my x minus 3s. You have a factor, you have a factor. My canceling here equals 1. And what's happening here is it's a hole, or they call that a removable hole. It's kind of like I took out a part of the roller coaster. Why? Because we just read, if you take 3, class, what's 3 minus 3? 0. And this one, 3 minus 3 is, and then 0 divided by 0, this is kind of like bad, right? 0 divided by something. This is not good. So what's happening is there's going to be a hole here. So it's not really a vertical asymptote. They just call that a removable hole. How do you know it's a removable hole? It's when you cancel.